Okay, so I'm ready to start. Okay. So I'm here to talk to you about special journeys I've been proud of being part of. It's really the convergence of journeys from an incredible group of top-notch scientists from the mainland, teaming up with the veterinarian entrepreneur here in the tropics. We've been doing this since 2007. It's really been, what I call a metamorphosis, right? A veterinarian trying to put a company out for cattle vaccine development, being personally touched by, very close by cancer, teaming up with scientists from the mainland to develop cutting-edge technologies to study human proteins. There's 20,000 human proteins in our body. They are the parts that make our cells live. They are important for infectious diseases to enter. When they malfunction, they can cause diseases like cancer. And they're, interestingly, they're also the new drugs. When a virus, Ebola, chikungunya, that we hear all the time right now, they gain access to our cells by interfacing with proteins on the receptors on that cell, going, fooling our cells, hijacking the replication system, and basically exploding our own systems to infect. Cancer happens when proteins malfunction and now the cells don't have any control and keep growing. When the proteins are supposed to protect us, the antibodies start attacking our own proteins, we get what is called an autoimmune disease. And we start, our organs degenerate. Prostate-specific antigen is a protein and it's measured to detect prostate cancer. The receptor is a protein that is measured to guide treatment in breast cancer. Vaccines are proteins that are injected in order to elicit an immune response that can protect. Proteins are the new drugs. 8 out of 20 blockbusters are proteins. Each of the top 6 monoclonal antibodies, which are proteins, sold $5 billion each year. There's $13 billion spent in focused protein research each year worldwide. Our journey has been guided by the pains of what we suffer as scientists. We want protein research that is more accurate. It's still pretty the same. We want it to be fast and efficient. We want to get more products, more discoveries. We want new information. We need more access to new information. The fuel of our journey has been the great talent that comes semester after semester out of the universities of Puerto Rico. You combine that talent with top-notch scientists and their input, and you can accomplish anything in biomedical sciences. Every good fuel needs a good additive, and we found lots of it. We found $12.5 million of competitive grant funding from the National Institutes of Health, the National Science Foundation, and additional support from the government of Puerto Rico through Rico and from the Puerto Rico Science and Technology Trust. Our journey is in stages. First stage, the creation of the human on a chip, what we call the HUPRO, which is 19,000 of our proteins in one glass slide. Now we can go from one protein, one test, to 19 tests in one experiment. 19,000. Second stage, FastMap. It's a HUPRO-powered monoclonal antibody development platform capable of generating incredibly accurate monoclonal antibodies. These are important as research tools. They are important in diagnostic kits, and they are also can be therapeutics. Third stage in the optimization stage, where we're integrating additional technologies that will take our platforms to the next level, including really revolutionary ways to access and acquire the data that comes out of our experiments. As we develop these platforms, we're also launching them. 2013, we launched the HUPRO as a product. We're launching the FastMap development platform this year. We're patenting the new technologies that will strengthen our platforms, and everything we hope to be integrated by the end of 2015. HUPRO is already sort of becoming the Intel inside of many platforms and assets that are being developed across the globe by ourselves and partners that are offering now these new assays, with new information to clients in academia and industry. Typical drug company now has a drug library, and they have a target. They have to go through each element of that library is that target to find a new drug. Tomorrow they have another target, they have to do it again, and again, and again. That's what we call all-to-one. We want to go to what's all-to-all. Just a few experiments, if the whole library gets our human on the chip, and decipher what all of those molecules are good for. I think that's better and more efficient. We're already doing this. We're starting a pilot with collaborators in Harvard. His name is David. He's also the founder of Ensemble Therapeutics. And in an email to his CEO, David said, in one experiment with CDI, we're going to do more interactions than he's done in a couple of years of worldwide biometrics. That's where we're going to go. That's all. The outcome of this is going to be accelerated and precise therapeutic lead molecule identification, accelerated and precise biomarker discovery, that means new targets, new diagnostics, and just plain and simply accelerate the research and development in the protein field. We're sort of at that rendezvous point. We've crossed the risky parts. We're out of the other side of the asteroid belt. We're looking for a few additional protein acts to help us reach our goal. Thank you.